students. Thank you very much for Dr. Jacquin for a nice introduction. I would like to present the project for milk, which has been conducted in this RISE program and is focused on milk quality. The consortium of this project was composed from 10 partners, from academic and research institutions, from SME, as well as from industrial company and governmental company, from 3 European countries, Slovakia, Ireland, and Hungary, and also from Canada and USA. The objectives of this project were research and innovation, so working of the researchers in laboratories abroad in the partner countries, then joint publications, then development of the methods for detection of enzyme activity in milk based on ultrasonic spectroscopy and on surface sensitive methods. Then it was transfer of technology, then organization of workshops and summer schools, and management of the projects. The scientific objectives has been divided on 2 parts. It is detection of plasmin activity based on detection of casein and short peptides. This is directly related with milk quality. And second was detection of lactase activity and optimization of preparation of lactose-free milk, which is connected with a solution of lactose intolerance of the milk products. Now I'd like to focus on main achievements of the projects. The first will be innovative methods of detection plasmin in milk, which is very important protease. Plasmin is a serine protease that is infiltrated from blood to the milk. In blood, it degrades blood plasma protein, including fibrin clots. In milk, it cleaves casein. The typical concentration of plasmin in milk is about 1 to 10 nanomolar. The plasmin is an extremely stable protein, which is inactivated only at 250 Celsius. The problems of plasmin is that high activity of plasmin causes cleavage of beta-casein with change of texture and flavor of the milk. So the bitter taste and milk gelation appear. This is not desirable for milk storage, but it is useful for cheese maturation. The problems of detection plasmin in milk is connected with several factors. First, plasmin is connected with milk proteins, mostly caseins, and it is necessary to optimize the methods of isolation of plasmin from caseins. Then plasmin can be activated and inactivated by another proteins, so it is very complex and very difficult to study systems. Also, possible interferences exist with other milk proteins that can interfere with sensing surface. So far, the detection of plasmin is not common in dairy laboratories because doesn't exist efficient test systems and cost-effective systems for this. But as I will show, in collaboration with our partners, we developed the assay which can be now used directly for plasmin detections. So the aim of this work is the application of surface and volume-sensitive acoustic methods for detection plasmin activity, then optimization of the method of plasmin detection in milk applicable for dairy laboratories. Now I will switch on the results showing how to detect plasmin at surface using acoustic methods. So the principle is quite simple. We're using so-called quartz crystal microbalance, where the plasmin can be detected at the surface of quartz crystal transducers. First, the beta-casein in the form of micelles is immobilized on the surface of the quartz crystals. The detection is based on detection of the frequencies of oscillation of quartz crystals, which are initiated by a generator which is applied from network analyzer. The crystal is placed in the special flow cells, and the solution or the analyte is pumping in flow mode to the surface. Thanks to development of Ginter-Sauer-Bray in 1959, we know that changes of the frequency of the oscillation of the crystals are directly proportional to the changes of the mass. For example, what we can expecting, if we apply plasmin at the surface of casein, the casein will cleave the plasmin will cleave the caseins, and this will result in decreasing of the mass at the surface of the crystal, and as a result, increasing of the frequency. And we really observed this. So you can see here the calibration curve for plasmin determination. You can see that with increasing of plasmin concentration, the changes of the frequency increasing. And this can serve as a method for determination of the plasmin in the milk. So sensitivity of this detection using QCM method is about 0.2 nanomolar, which is sufficient for practical application because, as I mentioned before, the concentration of plasmin in milk is in the interval of 1 to 10 nanomolar. It is interesting to compare sensitivity of this acoustic method with ELISA method. ELISA is enzyme-linked immunosorbent assay, which is standard method based on detection of the plasmin using specific antibodies. However, this method is not widely used in dairy industry, but it is very well known for another detection systems, for example, in medical laboratories. So you can see on this picture comparison of detection the plasmin in the same samples of different type of the milk, cow, goat, and sheep. And in each cases, you can see the slight less concentration detected by QCM in comparison with ELISA method. And here you can see the principal difference between these two methods. While QCM detects only active plasmin, which really cleave the casein, the ELISA detect a whole plasmin in the solution, even those which is not active and is connected with another milk proteins. So advantage of QCM in contrast with ELISA is that it really detects active plasmin in the milk samples, which is big advantage of this method. We also use another method for detection plasmin using high resolution ultrasonic spectroscopy, the method which has been developed in University College Dublin, and SONAS together with University College Dublin developed the instrument which allowing to use milk samples for detection plasmin and other proteins. The principle of the method is that in contrast with surface acoustic methods, we detect in plasmin in a volume. In a volume, if you present casein in a water solution, the casein and other proteins are hydrated. So around each of the casein micelles, the very densely packed hydration shell is formed. When the plasmin is added into the solution containing this beta-casein, then many short fragments of proteins appear due to the cleavage of casein. In addition, these fragments are also hydrated. As I mentioned, this hydration shell is very densely packed. So ultrasound or velocity of ultrasound depends on the compressibility and mechanical properties of the solution. As you can see on this formula, ultrasound velocity is indirectly proportional to the compressibility and density. So this means that if the content of less compressible water hydration shell will increasing, then we should observe increasing of ultrasonic velocity. And this has been really observed. So this is just very shortly the principles of this method. The method is based on the resonators. The cells contains at both sides the piezo crystals. The alternating voltage of high frequency from about 1 to 20 megahertz is applied. This induces acoustic wave. At certain condition, the resonance takes place. Changes in resonance frequency can be used for determination of ultrasonic velocity. Now the results. So as I mentioned, with addition of the plasmin, the hydration of the fragments increasing, and this results in increasing ultrasonic velocity. As you can see here, with increasing of the concentration, also increasing ultrasonic velocity take place, which is directly related to the number of peptide bonds cleaved. And here is the calibration curve, which allowing determination of plasmin in milk. So sensitivity of the system is even better than in the case of surface acoustic method. It's about 0.05 nanomolar of plasmin. Again, here is the comparison between this ultrasonic velocity measurement and ELISA method, and you can see again the similar approaches or similar tendency like for surface acoustic method except of raw milk when there is some difference, but this can be caused by the fact that raw milk contain various and very complicated, not inactivated plasmin inhibitors and acceptors or activators. The last or the second important part of the project was connected with lactose intolerance and optimization of enzyme cleaving lactose. So in milk, the lactose is a milk sugar, which is disaccharide. Lactose simply cleave the bonds between these two saccharides and creating galactose and glucose. Only these two saccharides can be utilized by the body. However, approximately 70% of the world population is affected by deficiency of lactase. That's why it's necessary to optimize the methods to prepare lactose-free milk products. This deficiency of lactase caused elevated concentration of lactose in colon, where it suffers fermentation by resident bacteria. This can lead to medical disorders after consumption of dairy products. So it is very serious diseases. The optimization of preparation of lactose-free milk products can be used or can be performed also by high-resolution ultrasonic spectroscopy. And you can see on this slide the dependence of the number of glycosidic bonds following addition of beta-galactase, which is enzyme similar to lactase. And you can see that at optimal condition, which is 40 Celsius, very fast kinetics of degradation of lactase take place. So in conclusion, we can say that we developed several innovative methods for plasmin detection in milk by surface and volume sensitive acoustic methods. These methods were validated in real mixed samples at the Hungarian Dairy Research Institute, Mosonmagyaróvár, with which we also developed optimization how to extract plasmin from the milk. We also optimized protocol of preparation of lactose-free milk using high-resolution ultrasonic spectroscopy. The important part of the project was connected with secondments. So about 265 researcher months has been realized, which is more than 95% of the planet secondments in the projects. We also realized 5 workshops and 3 summer schools, which were organized in different countries and at which participated more than 200 peoples, mostly PhD students. Also, a large number of publications was published, and also many presentation was at the conference. More details are in the web page, which is active and will be still active during at least next 5 years, because of the results which we obtained are still some in the process of publications, and also the research continuing in this respect. Also, I should say that this RISE program is really excellent possibility for making excellent research, and especially for training young researchers in high level laboratories all over the world. So we are very happy that after a new proposal which we submit to Horizon 2020 in May, we obtaining funding, and we now starting in the next year new project which is also focused on the milk, but will be focused on milk safety, and especially for optimization and development of innovative methods of detection of bacteria and antibiotics in the milk. So I would like to thank you, first of all, European Union and Horizon 2020 programs, as well as I would like to thank you to organizers of ESOF 2020 for giving me the opportunity to present the results of the project. Thank you very much.
Dear Thibault, thank you very much for your presentation. May I ask you a question? You developed this very interesting high resolution ultrasonic spectroscopy methods. How much interest did you receive from the dairy industry? Are they buying your techniques, or they, which countries are most interested in this presentation?
Yeah. So, yes. So we organized a special workshop in which we invited many representatives from the milk industry. And I think that at nearest 1-2 years, we will continuing in widespreading of this system, especially involving the small company PowerTech, which is focused on development of electronic systems. So we need to finalize all this detection system in complex device, which will contain not only the sensor, but also the analyzing systems. So at least I believe that in Mosonmagyaróvár, which is the highest testing system in Hungary, this plasmid detection will be very soon in the practice. And I believe that also in Slovakia, and maybe also in the another dairy laboratories, this will be widespread. At this moment, it is in the process of finalization of the product, which can be used as a kit, as a special measuring kit.
Okay, thank you very much. So I hope yes, the dairy industry will massively buy your new device. Thank you very much.
Thank you.
The organizers, can I introduce Georgios? Yeah, hi. So I'm now very glad to introduce Professor George Doudousis and give him the floor. He's working at the Arroyo University, and as a matter of fact, is concerned with non-alcoholic fat liver diseases. High fat and sugar food intake can lead to fatty liver disease, which can lead to obesity, diabetes, and cancer. And synthetic and natural food bioactive processing of antioxidant, anti-inflammatory, and lipid-lowering properties are under study. This project, MAST4Health, dealt with a compound from Greece, Mastia, which has very interesting properties fighting the non-alcoholic fatty liver disease. So please, George, can you start your presentation?
All right. Thank you, Thierry. So, good. Dear colleagues, dear friends, I would like to thank Dr. Thierry Jacquet for this invitation to present our results on the Mastiha treatment for obese with non-alcoholic fatty liver disease with the acronym MAST for Health project. Non-alcoholic fatty liver disease is a very common disease nowadays. Actually, 30% of the worldwide population have been diagnosed with the disease. So we decided to design intervention trial, all right, with a natural product from Greece called Mastiha, a dried resinous exudate of stems and branches of the Pistacia lentiscus of the Anacardiacea family, very common in the Eastern Mediterranean area. And this variety actually is cultivated in the Greek island of Chios, and especially in the south part. So Chios is located in the east part of Greece, and the cutting of the sharp surface results in actually congealing excretion, possibly due to the unique combination of climatic and ground conditions. And the mastic gum has been characterized as a product of protected designation of origin in 1997. Myself in Mastiha trees last year. And the attention that gave to this product is shown on the left by the presence of the previous president, Dr. Pavlopoulos, president of Greece, who visited the island during the cultivation period, the tears of the Mastiha and the crystallization form. So what's the chemical composition? Chemically, mastic gum is a complex natural product consisting of mainly three categories of substances: the polymer, the volatile fraction, which is the essential oil, and the terpenic content. Actually, the most interesting part, which has been given many publications before, and we know a lot of it, are the terpenes in the mastic resin, which are classified into neutral and acidic. And the main constituents of the mastic gum are the isomasticadienoic with the acronym of IMNA and the masticadienoic. Of course, there are other smaller compounds in the mastiha, in the terpenes fraction, but it seems that the most interesting ones are these two ones. So we knew before about the biological activities of mastiha, and the first publication was done in New England Journal of Medicine many years ago, showing that mastic gum kills Helicobacter pylori, and that was the antimicrobial action of mastiha. And then there are many publications from our group and other groups in Greece showing the antioxidant activity of mastiha in inflammatory bowel disease and other inflammatory condition, common as well. A cardiovascular protective effect of Chios mastiha gum by lowering cholesterol and glucose levels on healthy volunteers. The anti-inflammatory action of mastiha via restoring glutathione levels and downregulating the CD36 mRNA expression, chemoprevention of mastic oil against tumor growth in experimental colon cancer, and of course the most well-known, the effect on the gastrointestinal system and the treatment of functional dyspepsia. So there was a lot of literature before on the beneficial effect of mastic, And we decided to go ahead with designing an intervention trial on non-alcoholic fatty liver disease. So the first thing we had to do is to test the bioavailability of the two products, the main constituents of triterpenes, the MNA and the IMNA. So after an acute intervention period, we discovered these two products from 2 to 4 hours after the injection, after taking the pills of Masticha, and on the same time, well, actually a little bit later, 4 hours later, we observed a decrease and an important decrease in oxidized LDL. So the basic biological compounds became bioactive. So we designed a multi-center randomized double-blind placebo-controlled clinical trial aiming at testing the effectiveness of this herbal supplement in non-alcoholic fatty liver and non-alcoholic steatohepatitis. 15 partners participated, 9 academic and 6 non-academic from 8 countries, 3 clinical trial centers, Greece, Italy, and Serbia. On the right, you can see the map of the different clinical trial and the partners that participate in the project. The inclusion criteria was the confirmed non-alcoholic fatty liver disease and/or NASH, adults, obese, BMI above 30, with a LIF score, liver inflammation score above 2. So the exclusion criteria or typical exclusion criteria, alcohol abuse or drug addiction. The herbal supplement was administered in the form of capsule. Verum and placebo capsule had identical appearance and organoleptic characteristics. And the primary endpoint was the improvement of liver histopathology by measuring 2 parameters, the LIF and the CT1, as a metric of inflammation and fibrosis. And the other secondary endpoints were measured as well, like alteration by chemical markers, hepatic enzyme measurement, metabolomic profile, the gut microbiome in response to Masticha treatment. So as I said, participants came from 3 centers, Serbia, Italy, and Greece. We measure anthropometrics as well as magnetic resonance at baseline and 6 months after the treatment. In total, 38 participants were from Greece, 30 from Italy, and 30 from Serbia. In treatment A, which was actually that with a Masticha, 41 participants, and treatment B, which was the placebo, 77. And these are the initial number of volunteers that came to the 3 centers in Athens, in Novi Sad, and in Milano. On the right are the figures of the MRI with a different color from blue to red, showing the level of fibrosis. No fibrosis is with blue color, mild fibrosis with the green, and the orange and the red with severe fibrosis. So we selected those with mild fibrosis to participate in the project. These are the descriptives in the beginning. Don't look at numbers, just to show that between the placebo group and the Masticha group, there were no difference in time zero, as it was expected in any of the biochemical measures that was done and the different clinical parameters. So then, to verify the compliance of the Masticha group in the protocol, we measure the MNA and the IMNA, the major constituents of Masticha in plasma, and they are present here by HPLC. So you can see them in month 6 after the end of the intervention trial. And of course, they were not present in the placebo group. And at the same time, we measured by a platform, by the Orbitrap MS platform, the metabolomics, different molecules like amino acids, steroid hormones, and different phospholipids in the plasma of volunteers. So when we looked at the main outcome, the cT1 measure, we discover a decrease of cT1 measures in group A receiving Mastiha comparing with group B receiving placebo, especially in the high BMI group. So when we then try to look the clustering of different metabolites in the different ethnic groups, Italians, Serbians, and Greeks, there is some clusters. So different metabolites are present. There are some common, but there are some interesting. There was a trend among samples from different countries of origin. And when we looked at clustering according to the arm, the A, which was the Mastiha group, or the B, the placebo, we did discover different metabolites appeared. So meaning that there was an effect of the Mastiha since different metabolites increased or decreased. Also, we perform the gut microbiome after extracting DNA from fecal samples and sequencing the 16S ribosomic RNA. We processed this sequences. This was done by our group in the Fisabio in Valencia. And first we analyzed and compared the initial microbiota in time 0 from each country, 3 different countries. We observed that both alpha diversity and beta diversity are significantly different. There are some similarities between Italians and Greeks and less similarities with the Serbian group. And when we then looked for the difference in microbiota composition after the intervention trial for the 3 countries, there was a trend in increase of diversity, as you can see in group A in all different countries, although not statistically significant in this preliminary data. Now we have shown, we were able to show when all the data were incorporated that indeed there is a statistical difference between the placebo and the Mastiha group in terms of microbial diversity. And when we compare the changes introduced by treatment A and B, we observe that this dissimilarity respective of 0 is higher after treatment A, and we identify different bacterial populations. So on the same, in parallel with the human trial, a mouse trial was run by the Sanofi group, and in mice that they were fed with placebo and Mastiha for 8 weeks, no difference in weight gain or the calorie intake. But after Mastiha supplementation, there was a decrease in hepatic enzymes, a decrease in fat content in liver, in total cholesterol and total fat, a decrease in collagen and galectin. Both markers are reflecting fibrosis and inflammation, and a decrease in NFLD activity score, which was very important to show the effect of Mastiha on this clinical parameter, and also an increase in diversity of bacterial population, as was shown and confirmed the human trial. And here you can see the different the decrease in different bacterial populations, a decrease in Bacteroida and increase in Delta Proteobacteria in NASH and Mastiha-treated mice. So it seems that there is an effect on the disease, both in humans as well as in mice. That was a publication last year in New York Times, and the authors was asking, can this ancient Greek medicine cure humanity? Of course, we are not claiming that with Mastiha it will be the drug for non-alcoholic fatty liver disease, but it may help reverse the inflammation and the fibrosis. this was some photo from the kickoff meeting in Athens. Some photo from Masticha tree and the tears. There is a very nice museum in the Chios Island where the final meeting was held a few weeks before a lockdown from COVID in February 2020. And I think that was my last slide, and with some more pictures of the group in different meetings in Valencia, in Pisa, and in the Chios Island. So thank you very much.
Dear Georgios, thank you very much for your presentation. That is very interesting. So you have performed clinical trials, but for patients who have some inflammatory status, do they report that some relief of pain when they're using Mastiha? Can you confirm that for patients with non-alcoholic fatty liver disease, for example, we could see correlations of these inflammation markers, biomarkers, and the status, the progress status of NFADL? What do you think?
Yeah, so non-alcoholic fatty liver disease is a reversible disease, meaning that you can reverse the process from the initial stage to the inflammation and fibrosis if it is in the beginning. So, so that we targeted the initial stages of the disease before fibrosis advanced, and it seems that well, there was a decrease in the clinical outcome as it was shown from the MRI. But also biochemical, as I said, measures. So there's no pain actually from the patients. The patients do not say that I have a pain in this disease, but they say that they feel better when they answer a questionnaire related to the quality of their daily life. They respond that they feel better. But that has to be confirmed in the near future with more, analysis, and of course, the best would be to go on for a liver biopsy, which is not easy, but that would be the best option to confirm the improvement with the Masticha capsules.
Oh, okay. Well, talking about liver biopsies, maybe the next speaker, Paulo Oliveira, can have some advice on this. Can I introduce Paulo Oliveira, please? Yeah, so I'm glad now to introduce Paulo Oliveira, who is working at Coimbra University. So as we said, fatty liver disease shows a lot of symptoms that people may not feel first, and they don't feel any pain. So there is a pressing need for non-invasive and assessment of the disease stage, and MT-Fragra is tackling this problem. So please, Paulo, you have the floor. Thank you very much.
Thank you very much, Thierry. Thank you, friends, dear colleagues. Okay, good morning, everybody. Sorry for this small delay. It's a great pleasure for me to be here. So thank you very much, Thierry. So I'd like to actually to show you a little bit of our RISE project entitled Non-Invasive Profiling of Mitochondrial Profiling. Sorry, let's have something here on the way. Or mitochondrial function and non-alcoholic fatty liver disease. And because we are in a session related with healthy food, I'd like to share some images of certainly something that's not healthy food. So nowadays we are having a terrible public health, and I'm not talking about COVID-19. I'm talking about obesity that starts very early in childhood. So if I give you some numbers, you'll understand what I mean. For example, it's been estimated like 3 years ago that between 6 to 35% of the population worldwide has non-alcoholic fatty liver disease. And what is this? Is a condition in which we have an accumulation of fat in the liver that's not related to a large consumption of alcoholic drinks. And just in Europe, between 20 to 26 percent of population is known or has been detected to have this, and those numbers are severely underestimated. And of course, now with COVID-19, this is actually a problem because many publications suggest that patients with NAFLD or worse conditions, including non-alcoholic steatohepatitis, for example, or even cirrhosis, are in the greater risk of COVID-19 severity. In terms of risk factors, you have obesity, hypertension, dyslipidemia, type 2 diabetes mellitus, and the metabolic syndrome. And it was already referred here, most of the times it's discovered by chance. There is not a lot of diagnostic tools available. You can, for example, measure the fibrosis score. You can use an MRI, which is an expensive technique. Of course, we have liver biopsies. I don't think we want to have periodic liver biopsies for many reasons. You also have some morphological endpoints, fat liver index, and so on. And as I said, it's a real worrying that children each time more are having non-alcoholic fatty liver disease. So in 20, 30, 40 years, this is going to be a severe health problem. And there are many reasons. I'm not going to spend time here. Of course, bad lifestyles are a cause. We spend too much time without exercising. We tend to eat high fat, high sugar food. This alters, for example, the amount of fructose that we consume, affects our microbiota, as it was here described by the previous speaker. These causes can cause inflammation, accumulation of fat, and metabolic alteration. This crosstalk between the adipose tissue and the muscle is completely altered. So basically we suffer from metabolic diseases. And it's known that non-alcoholic fatty liver disease actually involves an interplay of not only nutritional, but also intrinsic factors. But there is something that we are now beginning to understand more in detail. There is this hepatic mitochondrial remodeling, which apparently is an important mediator of the overall process. And what are mitochondria? So mitochondria are basically our cells powerhouses. So there's our small organelles that exist inside our cells. Textbooks show this peanut-shaped organelle, as you see here in the left. But truly, they do have different types of shapes and formas. They can occur as a reticulum inside cells, so they produce the energy we need. They also collaborate in the regulation of calcium. They also produce a lot of metabolites that are essential for many of the cell function. They generate species that are derived from oxygen, which can be very, very dangerous if they are produced in a very large scale. And mitochondria also can regulate the way our cells die. So this cartoon that we actually produce in the scope of this project shows all the road from a healthy liver to a cirrhotic liver. So initially you start to have an accumulation of fat, which then can, if it's not reversed, as it was said just now, it can progress to non-alcoholic steatohepatitis, NASH, where you also have inflammation. Then from inflammation, you can have also fibrosis, and you have a severe cirrhosis. So people that actually don't drink any alcohol can suffer from cirrhosis. So what we study here is a mitochondrial Janus phase. So mitochondria are very important for energy production, but when they have this accumulation of extra fat, they feel very happy, and they actually increase in their number because they have now more fuel to consume, to oxidize, and to produce energy. So that something happens which makes them dysfunctional, which makes them to produce less amount of energy, to produce more amounts of oxygen-free radicals, and actually to end up causing problems to the hepatocytes, to the liver cells, in some cases killing those same cells. And this leads to an irreversible progression of the disease. And mitochondria are important, as I said, because they oxidize lipids. So the more lipid they have, as I said, they proliferate because it's a way of getting fuel for energy production. I also mentioned the reactive oxygen species, which are very, very important because they can not only regulate different normal physiological processes when they are kept low in mitochondria, but when they increase, this can lead to a dysfunctional organelle, to dysfunctional cell, and to cell death. And then in the liver, when this happens, hepatocytes are replaced by, for example, among other types of cells, by fibroblasts, which leads to fibrosis, which is very typical of cirrhosis. So there are many publications that's been described that mitochondrial dysfunction is associated with non-alcoholic fatty liver disease. We have here a paper from Piero Portincasa many years ago, also a member from our network. But then there's many things that need to be explored. It's what is the mechanism? What are the mechanisms? How can we measure this? What biomarkers exist for us to actually detect this liver progression, this NFLD liver progression? How can we reverse this in an effective way? So we just heard in the previous talk a very elegant way using a natural compound, and we actually been doing some more research on this topic. So our project, Mito Foie Gras, unites basically 14 institutions, of which 3 are companies, and plus a private association which deals with diabetics, where you find actually a lot of obese people with non-alcoholic fatty liver disease, and they all come from 7 different countries. So this is a very quick view of our project, our bad lifestyles, especially if you were in lockdown during COVID-19. At least myself, we tend to eat more, exercise less, and then we have this bad style which increases the amount of lipid into our livers. Initially, you have mitochondrial proliferation, mitochondrial what we call biogenesis, if you will, and then something happens in the middle of the way which leads to a decreased lipid oxidation, decreased amount of energy produced, increased production of reactive oxygen species, and this all integrates into this process of a progressive mitochondrial damage and progressive liver damage. So now you have NFLD going to NASH, and then later on, if it's not reversed, to cirrhosis. So the specific goal of Mito Foie Gras is to identify innovative biomarkers and non-invasive methodologies for mitochondrial profiling in the context of NFLD and NASH. So those are the work packages. So in the first work package, we go for very fundamental science. What are the mechanisms of mitochondrial damage, metabolic remodeling, in the context of the transition from NFLD to NASH and to worse conditions? Then on the second work package, we develop tools with biomarkers, non-invasive technologies, even methodology that we can use in our own labs to try to study this continuum in different types of models. In work package 3, which connects with 1 and 2, we actually using our models to test some of those approaches, and models that may include cells, may include animal models, may include even humans, samples. And then we have, of course, a lot of science dissemination communication. It's a very important part of our work, management. But above all, we want to stimulate training and innovation in Europe. This is the 2 main strong points in our project. So again, those are the different work packages, each work package with different projects. When we are doing those different projects, we actually identified a few other sub-projects that were very important from new data. So you can see some of them are related with very basic science, others are related to development of methodologies, development, identification of biomarkers, ways of reversing, using, for example, mitochondrial antioxidant therapies, using olive oil or mushroom-based diets, also in animal models and in humans, to reverse the phenotypes. Physical activity, which is a well-described manner to actually try to reverse a little bit the progression of the disease. So this is our 3 types of models. As I said, I'm not going to enter in a lot of results because I don't think this is the objective. So we tested, for example, the presence of biomarkers in circulation. For example, this MOTS-c, which is a mitochondrial peptide, which is apparently detected in circulation and could detect if what is the condition of the liver, or if it can actually, if it is injected in animal models, it can decrease obesity. Detecting circulation of mitochondrial components that are related to the inflammation. This is very, very important, especially in the liver, using mid-range infrared fingerprints in serum to try to predict which stage the patient is at. Detecting mitochondrial circulating DNA, which is very pro-inflammatory, among many other methodologies that we use. So creating value and innovation. As I said, we have companies working with us. They are working with us to develop novel ELISA tests, for example, to detect mitochondrial DNA in circulation, to detect mitochondrial components that can be originated from the liver, or actually from other tissue, as long as this increases the overall inflammation in the body. We are also using novel mitochondria-derived antioxidants, very new, to try to decrease the amount of oxidative stress, the oxidative burden in the liver, and with that increase or try to revert a little bit the liver condition. We have animal data, which are very, very, very promising. We also did infrared spectrometry to try to identify or to stage patients. So this is actually the first, I think, concerted effort to have this critical mass of human resources, PhD students, more senior staff, staff from different companies, so to can evaluate mitochondrial function in a whole for the diagnosis, staging, and treatment of NFLD. So of course, we are also training these people using workshops, schools. We're trying to also to form future entrepreneurs that can create their own employment and create innovation in the European Union in this field of biomarkers or clinical or marketable applications, for example, those antioxidants or different formulations. So I think overall, so far things are going well. Just a few considerations. This was our kickoff meeting in Coimbra, so like more than 3 years ago. Time actually flies a lot. Then we met more often. We actually were meeting quite often. This is when we signed the consortium agreement in Germany in the same year. Some images of different secondments, which I think went very well. We have several papers already out, and several others will be coming out as well. But we have to take care with the company intellectual properties as well. Some more people. This is, for example, staff. One staff member from one of the companies working in an academic institution, and he says it worked very well for us. Just 2 reviews that we started. That we have more coming out, more original papers coming out. This is also presentation of data in different meetings. This is one of the research in the left is Filomena. So she does a comment in the company Ouroboros. She actually identified that one compound that normally used to study fatty acid oxidation is actually interfering with a lot of other things. So commercially, this is actually a very large discovery. So it means that most of the commercial kits actually are not doing their proper job. So another meeting, this time in Barcelona, with several of the PIs that are involved in Mito Foie Gras, where we took advantage to actually to interact. We have Facebook, Twitter, and website that we try to update. And something that's very important. So besides innovation, which is critical, besides training staff, there's something which is very dear to us, which is reaching the society. So this is taxpayers' money. We need to tell them that we are spending wisely all their money. So we actually did a lot of activities. I'm just showing some that were done in Portugal. Some were also done in other countries. For example, we went to a senior citizen place. Of course, now with COVID-19, this would be impossible, where we asked them to make activities with us, to know what's non-alcoholic liver disease, to present the project. Things went very, very, very well. We were also present in a lot of sporting activities. This is a Portuguese Cup in trampolines. My daughter is actually a national vice champion in tumbling. So we took all this opportunity to bring people from the projects, from this RISE and another ETN that we also have, and interact with athletes, with the public, with parents, We were also present in the Coimbra Gym Fest, which was a very large international event in Coimbra, but in gymnastics. My daughter is the one in the right side, so we interact with coaches and athletes and parents. And then we have a very large event, which is the Coimbra University European University Games, which brought here more than 4,000 people, including close to 4,000 athletes. So we did a lot of interaction with athletes and referees and participants and just general public. We made some cartoons. We made also some comics. We did this also in collaboration with our ETN. So we took the best of the two worlds. So we did games with them. We met some previous Olympic game gold medal winners that said that we are having a very nice work. So we got feedback. And so basically we were teaching what's non-alcoholic fatty liver disease, how to avoid it, what healthy foods people should take, how to tackle this, and of course showing that we are all contributing for innovation. So thank you very much for your attention, and I'm happy to answer to any questions you may have.
Dear Paulo Oliveira, thank you very much for your presentation. Indeed, you have done a great job in communicating, not only within your network, but also to the general public. Thank you very much for this. Talking about science and the techniques that you developed during your project, how do you feel, how is it received in the hospitals? Can you transfer these techniques to the hospital? How are the medical doctors reacting to your techniques? What's the status on this, at least in Coimbra, for example?
Yes, that's a great question. We have in our consortium several medical doctors, not from Coimbra, from other hospitals in Europe. I'm talking Bari, for example, in Italy, and we are developing in the short. It's actually a short time frame in the project, so we not expect to reach the market or to reach a clinical application, because a biomarker needs to be very well established and validated. But it's been even from not only within the consortium but outside, and we've been discussing this with internal medicine doctors here in Coimbra. If the 2 or the 3 ELISA kits we are developing reach the market and the clinic, this will be very, very important. As well, if the mid-range infrared methodologies we are trying to develop to stage patients, and we have been doing a pilot study with real patients in this clinic in Lisbon. If we confirm this is a nice way to stage the disease, this would be a great finding. So we don't need to be invasive, but you know exactly if it is a benign NFLD, if it's actually going towards NASH, or if it's actually going towards cirrhosis. And of course, I'm not counting with all the fundamental knowledge that's been also translated into different types of data that can actually be used to produce, if not now, in future projects, new types of innovation that can be translated to the society and to the clinics.
Okay, thank you very much, Paulo. I would be happy to introduce now the next speaker. And so this is Dr. Jeffrey Paul Bray from Bournemouth University. So the network, FoodSmart, developed a very interesting application that consumers can use on their everyday life, hopefully. And Jeffrey will talk about this today. Thank you very much, Jeffrey.
Buongiorno, good afternoon. It's a great pleasure to be able to provide an overview of our European Union funded RISE project, FoodSmart. This project chimes very well with the session's theme around improving consumer choices. My background is in human behavior and consumer behavior, but with this project, there was a large consortium that included pluridisciplinary interests that were required to bring the project to conclusion. Our partners included Bournemouth University, where I'm from, that coordinated the project, the University of Macedonia from Greece, that brought technical expertise from an ICT perspective, the Institute Paul Bocuse from a culinary science perspective, Copenhagen University, again with consumer insight, and Ronger and Partner with food service expertise. So 3 academic institutions and 2 industry institutions doing secondments with each other. The problem that we set out to address with Project Food Smart was that of ill health and obesity caused by eating habits, specifically eating out of the home. Now, eating out of the home is growing across Europe, and in the United Kingdom, before, of course, the COVID lockdown, it represented 1 in every 6 meals consumed. And the problem is that meals served out of the home tend to be higher in calories, higher in fat, higher in saturated fat, and served in larger portions. And the problem is that the consumer rarely understands fully what it is that they are eating out of the home, where they can be a lot more careful when they're preparing the dishes themselves. There is a clear link between the increase in eating out of home and rates of obesity and other non-communicable diseases such as diabetes type 2. And the societal costs of dealing with these non-communicable diseases go far beyond the economic, but of course the economic is the easiest to measure, and it's estimated to cost £920 billion every year from the year 2025. In the United Kingdom, which is not untypical of a number of European countries, 34% of the adult population is predicted to be clinically obese by 2025. So the key issue is that consumers don't know what they're eating when they're eating out of home, and they have no reliable way to find out. Information provision is increasing, but it is still inadequate in many settings. And we chose to focus our research on the workplace canteen because many people throughout Europe will eat 5 main meals at a workplace canteen during an average week. And so the Food Smart project aimed to understand consumers' desires with regards to food provision when eating out, and the most effective manner to share that information with consumers. And a technological solution was quickly revealed to be the best way to do this. Our project was organised around 7 work packages. Work packages 1 and 2 were led by Bournemouth University and our team here. Work packages 3 and 4 were more technical and were informed by the evidence that was gleaned from work package 2, and they were led by our Greek partner at the University of Macedonia. Field testing of our solution and prototype validation was led by the Institute of Paul Bocuse in France, while dissemination and training, which it appears last on the list here, but of course occurred throughout the project, was led by Copenhagen University in Denmark. So I'll focus firstly on work package 2, which was seeking to understand what information consumers would like to receive. And we conducted extensive field work in the United Kingdom, Denmark, France, and Greece. And it is interesting that principally the findings are common across those 4 countries. Of course, there are small nuanced differences, and they are accounted for in our numerous journal publications related to the project. But fundamentally, consumers were interested to understand the value for money and cost of dishes, nutrition profile of dishes, and naturalness. In France, actually, the provenance of ingredients became quite important as well. That was of smaller importance in other countries. Interestingly, consumers in all countries were keen to access additional information on dishes through a technological solution, rather than asking waiting staff or catering staff in an institution. They would have far greater trust, it appears, with receiving information on a computer or a smartphone than they would from a waiter, waitress, or catering staff. We then looked in some detail as to how food information is most optimally presented. It's no good us coming at this from a nutritional perspective and providing complex data that the consumer can't access or doesn't have interest in accessing. So it was revealed through this consumer research that in order to be effective, consumers needed to receive the information that was salient to them. Of course, different consumers have different interests. And so there needs to be a platform whereby information provision can be personalized to each individual consumer. And also we revealed that the traffic light labeling and information boxes were the most easily accessible means of delivering nutritional information. Okay, the findings from this consumer research led into our technical design. So it really was evidence-based practice, and a smartphone application was deemed to be the most appropriate tool to develop. And from the consumer research, we developed a MOSCO. And MOSCO is common parlance in technical spheres. It simply relates to a specification outlining what we must provide, should provide, could provide, and won't provide. So it was determined that our application must provide full ingredients and calorie count of dishes, nutritional profile as per the traffic light system, rigorous information on allergens and preparatory methods such as kosher and halal, and dietary requirements such as vegetarian and vegan. There's a range of other aspects that we did introduce to our application, but were not deemed to be as critical, and some key aspects that we were not going to include. For example, information on allergen traces. Restaurant kitchens and food service providers simply cannot provide allergen trace information given the wide variety of ingredients that are present within kitchens. So the FoodSmart project developed a smartphone application, a technical solution that allowed consumers to assess precisely, efficiently, and in a timely manner their food intake, and that delivered personalized advice when eating out. After an initial attractive intro page, our application led consumers to set up their personal profile. So what you can see on the screen there is two screenshots. On the left is the main menu, and on the right it takes you in to the diet type selection, where consumers can select whether they're vegetarian or vegan, for example, whether they are allergic to any of the recognized allergens, and whether there is a specific calorie limit that they would wish to observe. Those personal preferences were used to adapt the caterer's menu, bringing to the top those dishes which were deemed most suitable to that diner. No possibilities from the menu were excluded. They were simply shaded and presented at the bottom of the menu. So our idea was not to restrict consumer choice, but to rather, through choice architecture, influence consumers towards the most suitable and the most healthful dishes. Of course, somebody might identify as being vegetarian, but still may eat a meat-containing dish if it's their favorite. So it wasn't strictly applied. And in each case, as you can see from the menu on the left, there is additional dish information. And by selecting any of the dishes, far greater information is provided, with a full ingredients list on the right and nutritional information using the traffic light system that has become well established in many countries on retail packaging. The application was extensively field tested again across the United Kingdom, Denmark, France, and Greece, and the findings from that field testing again are in peer-reviewed journal papers. And we then moved to the commercialization of the project in order to fully realize the impact that it could have. And we presented our project to a number of large-scale contract catering organizations. And in every case, they were highly interested in the findings, liked very much the evidence and the ideas, and have taken the evidence from the project to develop their own in-house app that includes their corporate branding and additional functionality, such as the ability to pay, which was a little outside of our remit. So all of the ideas and intellectual property of this application have been commercialized and are increasingly being commercialized, but you won't see our actual app in a canteen near you. Our FoodSmart app is on the Google Play Store and is free to download for anybody that would like to have a look at it in greater detail. But as I say, it's unlikely that you'll have a canteen near you that is using this particular prototype. We disseminated the project throughout through a project website, which included numerous video updates as well. We have had numerous journal articles. There's 5 featured here, but another 2 have come out actually just this week, which aren't added here. And similar to Dr. Oliveira, we focused a great deal on public engagement, publishing through public audience articles such as The Conversation. And we had an article published in the Metro, which is the UK's largest circulation newspaper, with 1.5 million daily copies printed. I thank you for your attention as I introduced our project. The only slides remaining are my references and references to the early publications that we have from the project. Thank you very much.
Thank you very much, Jeffrey, for your presentation. That is very interesting. As you said, it's very unlikely that canteen in the workplace nearby where we are staying would not have this application. What would be the procedure? Should they contact you to put their information in your application? How do you load your applications with information from so many different places around the world? How does it work?
Yes, so actually the process is very easy. So as I say, the application is freely available on the Google Play Store, and naturally all of our findings and the code for the application are open source and so available to anybody. Within the project, Work Package 3 was to develop a database which enabled contract caterers to automatically input their recipes in a format that could be read and delivered through the consumer-facing application. As I say, our research was mostly focused on contract caterers and workplace canteens. And in these settings, the providers have very rigorous recipe specifications that are already existing in a database. And so it is very easy to import those into the database for access through our app. But as I say, a lot of the large contract caterers are now using our findings to develop their own apps. And so I think we'll see significant change in this practice in the coming years, because consumers are increasingly demanding this additional food information. They're getting used to seeing it in supermarkets, and they're demanding it now when they eat out of home.
Thank you very much. I would like to pass on some questions from the audience. One was arrived at the start of your presentation, Jeff, so maybe I think you addressed the question, but just to let everybody knows. So besides the clinical application of all these very interesting new approaches, I would like to know, reconnecting to the title of the talk, if there are right choices that can be taken by consumers. So I guess your application, you described that with your application, you can easily identify the food and quantity and calories that can be used. You can comment on this.
Yes, actually, the evidence is a little bit controversial, the clear link between providing consumers with information and actually changing their behavior. But certainly it is intuitive to believe that providing consumers with greater information around what they're consuming will nudge them to make more conscious decisions. And especially in contexts where we may be eating 5 times a week, then small changes in behavior can yield over time quite considerable changes in health and in the calorific content of what we're eating and the nature of what we're eating. Currently, that information provision is simply missing in so many contexts, which really does preclude the consumer from making sensible or making the optimal choices. So providing information to the consumer is, in our view, a key first step to changing behaviors.
Thank you. There is another question. I leave it to your comments, although I think you addressed it already. Don't you think that the creation of an application about the nutritional profile of different foods can increase the eating disorders in people who are already affected by them? Maybe the only right choice to be done should be to increase the quality of the products in the restaurants, increasing the idea of healthy food and healthy eating across the world, excluding the possibility to do a bad choice.
Yes, I understand this question and thank the contributor for making it. However, what I would say is that there are an increasing number of people in Europe and across the world that have food intolerances. For example, the rate of celiac disease is increasing. For these people, they absolutely have to know what is in the dishes that they're selecting. So we're providing a great service to those people that have food intolerances. For those with eating disorders, there are already a plethora of applications that essentially can calorie count for you. However, these are based on generic recipes, not specific recipes, and so provide inaccurate information. So I don't believe that there's an additional concern around eating disorders, because anybody that is that may be subject to that is probably following an app already that is inaccurate. And so providing accurate information can only be to the good of anybody that wishes to inform themselves.
Okay, thank you very much, Jeff. I still have one question, probably addressed to Tibor Yannick. It is the following: milk from animals is a dying industry. Why aren't we speaking of more sustainable and healthier options like plant-based options? Please, very short, because we only have 1 minute left.
Yes, I think that milk is a very important product and cannot be replaced by any plant products. Maybe only soya milk can a little bit be very close, because milk is a nutrient which contain many proteins which are very important for the health, and also the sugars and fatties. So I think that we cannot avoid this.
Okay, thank you very much. So as a last comment, would you give some recommendations? For example, somebody drinking soda like 1 liter per day, what's the status of the liver and NFA, non-alcoholic fatty liver disease? Georgios, would you like to give a comment? You're muted, Georgios.
Okay, so could you repeat the question? Was about the soda?
Yeah, what's the status of the liver of somebody drinking 1 liter of soda per day?
Well, I can't reply about that. I mean, there are healthy recommendations for avoiding non-alcoholic fatty liver disease, and mainly the basic is the reducing weight. So I can't say that soda, 1 liter of soda would be a healthy attitude.
Okay.
Yeah.
Well, we are running out of time, so I think I should close the session. Thank you, everybody, all speakers, for your fruitful collaboration. Ladies and gentlemen, thank you very much for being here with us today. Please enjoy upcoming ESOF sessions where you will have all the chances to meet our WISE project. For example, there is one tomorrow at noon about nanomedicine, and one on Sunday at noon also about innovative approaches to youth-centered development of healthcare solutions. Thank you very much to all. Bye-bye.
Thank you.
Thank
Bye.
you. Bye-bye.